Awesome. We're back. All right,
No,
Tudor.
finally.
What all right. So I think the gist of this one is we're gonna let you drive and kind of given the learning objectives we talked about last time and so forth, we get to watch you the maestro at work. And by the way, just to maybe add some color to that. I mean, that was actually one of the funnest things is like when we were talking about the Twitter widget, having you kind of watching you kind of solve that problem was super cool. So, all right, over to you.
Right. Okay. So yeah, last time we talked, we said that maybe so one of the things that came out of that was that the just exercising the language, the programming language, so Smalltalk in our case, is not necessarily doesn't necessarily directly lead to this idea of moldable development, and what makes Glamorous Toolkit slightly different than other other types of propositions, other kinds of environments. So I was thinking that to pick examples that are more conducive to exploring what does it mean to to employ this new way of thinking. Because one of the things that for us it's important is that while we have applied it extensively to programming in Smalltalk, moldable development is not Smalltalk specific. It just so happens it was just easy to explore in this environment. But once you know what it is, you can go and explore it somewhere else. But before you explore it somewhere else, right, we should know, it would be useful to get an understanding of, how deep, what are the things that are possible, and then we can go and figure out, variations. So, okay, so I think
just a quick thing.
Sure.
And I'm just delighted, and I presumably you're delighted too, that Jack Rusher and others in the closure community are picking up that word, right, to describe something that, as he said, this describes what I've been doing for decades, 20 plus years in Common Lisp, Smalltalk, and so forth.
Yeah. So I think it's super exciting. I do think that maybe not everything is visible. So let's have that conversation, maybe in the near future, comparing, because again, like my worry is that people will look at this and associate it with the 10% that is more visible. And and that doesn't necessarily solve the problem. So, but yes, I am super excited that people are looking at this, that they are exploring, and that sometimes comparing to Glamorous Toolkit, it's very nice.
We feel the same way, by the way, in Lisp when people say, we have a REPL. We're like, yeah, you have the very, most visible part of the REPL, but you don't have REPL driven development, where everything is designed to be, interacted with and changed at runtime.
Just to riff with you,
right?
And like when people talk about DevOps, right? It's like, oh, we have CI/CD, so therefore there's all. They're like, well, man, maybe an incomplete expression of the whole.
So I'm not suggesting that that we have the complete answer either. I'm only saying that. So I'm super happy that people look at moldable development. I think it's great that people associate with things that have others have done before in some medium.
So I think we were saying we hear you and understand.
Right. And so, but our goal is just to say, so we still do not yet know how to explain what we do. We don't yet know how to do that just yet, but let's see, maybe we've improved a little bit. So one of the things actually that we are spending time on recently, or since recently, is trying to find exercises that are not too large, but that still kind of capture the ideas that we have. I think that, you know, when we have explored a bit together, we looked at, for example, how do I, you know, there was this Twitter example where we took some JSON, some export from Twitter, and then we created a little browser for that, right? And then there was the parser and of the book, right? Contents and maybe a little visualization of that, and that's interesting, right? But then here we are still into a situation where we are exploring external data. So this is not necessarily about the system that we're working with, or a system or some system that we want to maybe reason about. But the original idea of moldable development comes from there, comes from from that. From looking into the system. So one of the things that we worked with recently is this is a piece of work that Oscar Nistras done together with me. So he's just preparing a lecture. Oscar Nistras was a professor at University of Bern, and he's now Professor Emeritus. And he's giving a lecture tomorrow. Not tomorrow, this week, for the students at the University of Bern. And the students there, it's an invited lecture, the students there, they had to implement a certain game. And so we implemented the same game, but we did it in Glamorous Toolkit. And the goal here was to do it once, do it kind of the classic kind of way. So let's say, for example, test-driven kind of design, and then try to see if we tried afterwards to expose the design, to try to visualize the inside of the system, and then observe whether or not the design changes. So the act of explaining the inside of the system, does it affect the design of the system? That was the exercise that we went through.
Interesting.
And so we spent a few days on doing this. So it's basically something like a week of an exploration. And this was kind of interesting. I knew the answer up front, but
yeah.
But I think it's an interesting thing, and well, you let us know if it's interesting enough for you. So let me show you a bit. What do I mean by this? So the game in case is called Ludo game. The Ludo game. This is let's say if I'm this one here. So you have 4 players, and you can, let's say, player A to roll the die, and you can roll the die. If you do a 3, you cannot move, right? You can only move first one. So these are here, A, B, C, D. You can only move once you hit the 6. So I'm keep double clicking here, right? Oh, look at this. C can work, right?
Got it.
So now I can move. So now I move there, which is great. And now C is still C's turn.
Gets
so
to go again.
now
Yeah.
C is to move. So I did the 4. So I'm just double clicking on which one, and it moves there. Okay, and that's kind of the idea. And then of course, at some point you want to. The interesting thing is when a token from another player, maybe can come and capture. So basically the goal of the C tokens is to get here, right? So go all the way around and then get here eventually.
Right.
And the goals of the other ones is to prevent them from doing this. So everybody has the same goal, and I can do, oh, look at the C can move again. So I'm gonna take C out. Oh, look at this. Okay, so, okay, player A can move, great, right? So I'm moving now like this. So this is kind of nice, right? So that's the game. So this is the game already implemented, basically. So now we have that. Now it's kind of, this is not so, I mean, clicking here is nice from a user perspective, but you don't really want to do that if you want to, for example, test this a little bit, right? So if you want to test this, you want to take this here and then, do something like, so now I'm in an inspector here and the Ludo game knows how to present itself. So that's kind of like the UI that can be shown to somebody in a separate window, but you can also see it here. So that's kind of neat. But then you can say, I want to say here, I want to roll a 6. And now B has to move, right? And I'm moving there. And then I want to roll another 6. And now B is also still moving, right? And now I want to roll a 1, 2, 3, 4. I want to roll a 4. And now B is going to move. All right, so now B captured C. C had to move back. So it's time, right?
So it allows you to test certain scenarios.
Right. So now I can, this is kind of, it's kind of, this is kind of similar to the REPL-based idea, isn't it? Kind of, right? So it's basically, I just took a REPL, I just had a self here, which is nice.
Except
but
you
then
got
of course
a
I
nice
could also
view of the game.
Right, which is, so this is the first thing, right? This is the first thing to notice here. So typically when we think about, when we think about the UI is something that is like the end goal that essentially the developers never sees. Right. You only see it to check whether or not what you've produced is right, but you otherwise never see.
For sure.
Isn't it kind of interesting?
Yeah.
Right. So like, just think of it, like how many.
Can you say that again? What do you never see? The kind of the projection of the game state onto the board. I mean, is that what you?
The end UI, right?
Yeah,
the end user interface.
Yeah.
Like if you look at the screen of the developer,
it's filled with code or like a console printouts or.
Right.
And even when you actually get to test it, right? Let's say if you do a test-driven development thing and you're writing your test, right? You write your test, and then you never get to see the board. Yeah. And that's like an interesting, that's an interesting thing. And then the question, and then we complain about the gap of communication between developers and non-technical people.
Yep,
but isn't it interesting how we expose them, like they just spend their time in literally seeing different things.
Yeah.
And when you see different things, right, those things come with a language. And so when you see those, right, we literally incentivize people to build different languages. Now, of course, this idea of DDD, domain-driven design, is to take that language and put it in the code. But the question is, where do we put the picture in the code? Isn't it like an interesting, easier thing to do?
Yeah, in fact, I've been taking notes in the Slack channel. I wrote down like a REPL, but you have a fantastic visual representation of it. I think comes in the parenthetical at the earliest stages of development. And I think Eric, we were sort of laughing, but it's like, oh no, actually, it seems pretty important.
Yeah, for sure. Yeah. Oh yeah.
So this is at the beginning, right? So we just got started with it. So now we have some other case over here. Let's say you see C is to roll the die, and I want to roll a 6 now. So what happens now is that I'm doing this, and it gets there, right? So now C captured B, and B went away, right? Because I just took this. So it's kind of, it's this game. So I can explore it, and I have this REPL thing, but I can also see the game. And the reason I can see the game is that the game is available at the lowest level of representation. I do not have to climb the abstraction ladder to see something that is visible at, when the thing is finished, right? That's why hosting the view within the inspector makes this possible. We just started.
Hey,
we just got. Go ahead.
Can we just maybe this is too concrete, but like, okay, so does this mean what is the internal representation of this board? Like I remember
Isn't it interesting, right?
Yeah.
'Cause
Like
that's the interesting thing.
just to
Yes.
add some more fidelity to that. I mean, I remember Eric in the closure book, or one of them is like, let's do the Conway's Game of Life, and we can represent it this way or that way. And it was a kind of it was all about sort of like creating the right data structure for this. So I'm like dying to know kind of how you answer this question.
So you're asking what's the representation of this, right?
Yeah.
And this is where it actually gets interesting, right? So up to here, it's just something that is still imaginable in other environments, but now we want to dive into that representation of the game. So let's do this. So here I have players, right? So one of the things I can see is that the Ludo game has players, right? And I can see here that these players, they have, player A has token A, which is in play, player B and A. So it has two tokens that are one in play, one in start. B has both of them in start. C has both of them in play. And D has them at start, right? Because that is how it was, right? So C has two tokens and A has one token available, right? And now I can go inside this player. Right. So what happens now, right? Because so now I went to a player A, and now it tells me I'm looking at the board, but I'm looking at the board from the perspective of this thing that I want to look at. Because now the whole board is not interesting as a whole board. Now it's interesting from this little my perspective over here.
Right.
And this is where it gets more interesting, right? So in fact, the interestingness of Glamorous Toolkit happens 1 or 2 or 3 or 4 level deeper than whatever you can see immediately. Okay, so these are things, right? And then what do I see here? Okay, look at this. The Ludo player has tokens, and I can see that I have a view over here with tokens. So just 2 of them, and now I can see where are they? These are the tokens. Right. So again, like here, we can navigate this in quite interestingly, right? We guide ourselves through the views. So up to now, we haven't looked at any piece of code, basically. But you can still imagine yourself, right? I mean, I believe that you can imagine, you have a mental picture of what the data structure here is, right? So if you would have to maybe draw some, I don't know, some diagram of sorts, right? I believe that you can see that there's a game which has players, a player has tokens, right? And then even the token knows the position onto the board, because otherwise it cannot draw itself. We don't yet know how, but we know it's possible, right? So, and again, like we've done all of these things so far, and we haven't looked at a piece of code yet. And so now we might want to say, okay, so how is this token? Because kind of is, it kind of, I don't know exactly, how does it know? How does it know to draw itself? Because it has an access to the board. It's kind of interesting here. And it's kind of intriguing, in fact, right? So I can see here, if I now look at the raw, the raw view, I can see, look at this. It has a square. And if I look at the square now, oh yeah, the square knows how to position itself as well, because it knows where it is. And then from there, like, how does it know to do this, right? It probably has a game, right? And then I go to the game where I was at the beginning.
Right. The weirdest thing to me about this representation is the circular references.
Why?
I want to avoid them as much as possible. I want to have a top-down hierarchical system that's easy to. Why? It's easier to reason about. You don't have to worry about links getting out of date or something like that. Setting up both sides of the, of the system.
But then of course you're gonna worry about So the thing is, I don't believe that there exists a single way to decompose things. And sometimes it makes sense to have a top-down thing, and sometimes it makes perfect sense to have bidirectional things. So, for example, when you're choosing between the two, you're also we can also say that we're choosing a trade-off between how easy it is to set up the model and maybe change parts, for example, or maybe I want to distribute it, right? And I want to put it somewhere else. I don't want that to come back to me, for example. So this is on the one hand, right? So there, I really benefit from a tree rather than a circular graph. On the other hand, I have another trade-off, which is queryability. So when I have a bidirectional system, it's super easy to query things. It's super easy to formulate sentences against my model.
Right, because you can say something like the squares board, or the
squares board, exactly, yeah. Right? I just can formulate.
I mean, that makes total sense. Yeah.
Right. So, and again, it's not about here. I'm not suggesting that this, first of all, this is not the only way in which we could get this information. So if I would have just a square, and the square would not know the game, what we would like is we would like to inject the game into the context, right? So you would pass it as an argument, right? For example, when you would do your call, whenever the square would reason about something, it would be within a closure where game is bound basically somewhere, right? Because that's at the end what you care about. Gene, you wanted to say something?
No, I'm just laughing. It's logically, of course, that's what you do. It's kind of where my head's at. Yeah, it's interesting.
Right, but but here's the thing, right? So first of all, before we do the other one, right? Bidirectional, to me, a bidirectional model is much simpler to deal with than the other one, because I never know exactly how do I want to do it. For example, here, you can say,
you just do it every way. Anything that could possibly need to reference something else will just make a pointer.
It's very simple at the end. It's very simple to start with. I don't know, I don't necessarily want to live up with this, but then it's actually not
bidirectional
always...
is true. I'll let you speak. Sorry.
No,
I'm
because I'm just improvising here, so I don't know exactly. I don't have to.
It's almost heretical.
Well, yeah. I mean, I think it's kind of normal in the object-oriented world to talk about that. Do bidirectional. Bidirectional pointers.
I know of books, whole books which are written that says no, never do that.
And I remember in school, like one of the exercises we did was all about the design patterns you use to manage bidirectional references. Yeah. But bidirectional is good. I just think it should be done at not at the pointer level, right? So you should be, if you need a bidirectional reference, like if let's say you're using a relational model, you would have a table that joined the board table with the player table or whatever it is. And that's bidirectional, but it's not the player has a pointer to the board and the board has a pointer to the player.
Mm-hmm. Yeah. But very often that is also relates to whatever the database is capable of doing fast enough, or but it's not. I don't see necessarily why I need. So when I explore a conceptual model, why would I want to care about these details at this point in time when I do not yet know what is the most? But you're caring about the
details of your references. You're just changing the details.
Sure, but just a second. So how would you know, right? So here I have 3 levels, right? I have a game, I have a player, I have a token, and I have a square.
Yeah.
So what would be an interesting decomposition? Game, square, token, player, game player token square. Which one is more interesting? Both both are possible.
So, I mean, I think I would just do it completely differently. Like there would be some, I mean, just making it up right now. I don't know if this makes sense or not, but there would be some linearization of the pieces of the squares on the board, and a square would be represented by a number, right? Just a number, like a number. And then there would be a little bit of game state that said, you know, this token is at this location, this token is at this location, this, and then a little state about whose turn it was, and you know what the last die roll was,
right.
something
So
like that.
Here we can see it here, right? We say the Ludo game, it knows the squares, so all the squares are here. Obviously, squares.
Oh, you did do the same. You linearized it. Okay, cool.
Except that these are not numbers, right? This is an object. Because why do I want it to? Why do I want an object? Because first it was
the question.
First it was an object, right? It was a number. It was just an array of things. But why did we want to have it the first class? Why did we end up having a first class object here?
I don't know what's in
because there was nowhere to put this visualization.
Right.
And it's so interesting. Just think of this, right? So what does 2 mean and what does 15 mean? Do I have to keep it in my head? Or is it the job of the system to tell me this is what 15 means? Right? Because otherwise I would have to keep that map in my head. Maybe I would have a napkin somewhere saying what does 1 and 2 and 3 and so on mean, right? So that I can keep track of these things. But because I wanted to say, no, I don't want that. The principle is every time I deem a presentation, some human deems a presentation as meaningful, it is the job of the system to carry it forward. That's it. That's the principle.
And so you make a class and put visualizations on it.
Right. Now, isn't it interesting? Can you remember, can you go back to the Twitter case?
Mm-hmm.
Right? We took a JSON. JSON is a perfectly reasonable data structure.
Yeah.
Right? It's just a list of lists and has numbers inside. So it's, I don't need anything else. The computer doesn't need anything else. Right. I should be able to create a visualization or a view on it with just by working with JSON. Oh, actually, it's, you know, the current state of the web development is proof that this is absolutely possible.
Yeah. Yeah.
But we didn't do that. What we've done was we took a part of snippet of part of JSON, and then we created a Twitter class, a tweet class. And then in the tweet class, maybe we were going to have an author class, and then so on. And then each of them will have different perspectives over our system.
Right.
Now, but there's one other. Yeah, go ahead.
Maybe not to discuss here. I just put in a Slack channel. I mean, I think I know that cycles are bad, right? So like Eric projected the world.
With.
Yeah, it's like it helps to have a directed acyclic graph, a tree, right? And it's hard to have modularity when you actually have cycles. So maybe you can time box this to 5 minutes. Can you describe like how is it that you can possibly
walk the graph?
Yeah,
like without like a huge, I don't know. You got to keep track of where you've been so that you don't go back there when you get a cycle, you know. Do you not walk the graph much?
Well, what does it have to do with it? What does a cycle? So cyclic here means you have a bidirectional relationship, right? So we have the game, the square, the token, and then the token, sorry, the game, the player, the token, and the token has a square, and the square has a pointer back to the game.
Yeah.
Right?
That's a cycle. Yeah.
Okay. That is a cycle, right?
Yeah,
now,
this is great.
And so like you can't print it out. Because I mean, not just like
why not?
Because when you print out the square, which has a pointer back to the game, you're now going to print out the game again, and you're in an infinite loop.
Oh, look at this! I just proved you that I can print it out. Look, hear this. This is a square.
You didn't print it. You have a different visualization that you've customized. That's what I mean.
What
does
printing mean?
Well, that is something that you probably don't have, which we're used to in Clojure, or languages where you work directly in JSON, that you can just print it out. And
oh, you mean that I can serialize the data structure?
Yes, you can serialize it to a
Mhm.
format you can read back in. And
I
you can
see.
do that
And-
without custom work, right? I mean, obviously you could like say, well, the square is just not going to print out the game, right? But now you have to customize that.
I think I was just making more
Yeah.
fundamental things like modularity usually depends on not having cycles.
Right.
So it's just funny to me that there's this heretical notion here of like encouraging cycles. I just want to point that out. It's to me funny. So this is great. And I yield the remainder of the time back to Tudor.
Back to the chair. So, okay. So there are two things here. First of all, this is a thing where we're discovering the design. We don't yet know the design. We're discovering the design. When you're discovering the design, I don't necessarily believe that modularity is the first thing you want to look at. Modularity is something that you want to ensure through some constraints, because modularity is not something you design up front. Modularity is something that you ensure persists over time. But first of all, you want to find boundaries, right? And there's no single way to cut a system. And the question is, how do you know? How do you find out? What is the right thing to cut? How do you cut it? What's the simplest thing? And sometimes having a cycle is just perfectly reasonable. It doesn't have to, like if modularity means, right? So one of the interesting concepts in the domain-driven design comes with is this idea of bounded context. Bounded context is an arbitrary thing that I draw, I pick. I pick it like this. Whatever happens within the bounded context basically has no real, it doesn't really affect the modularity of the system as a whole. And so if things are meaningful in this way, and maybe it's cheaper, maybe it's faster, maybe it's more expressive, maybe it's more readable. There are all sorts of reasons. Maybe it's simpler to test.
Yeah, it's funny.
Why are those not interesting considerations? Because I think they should be, right? Because the problem is many of the rules that we're driven by were created in an environment which is incredibly poor in expression. Like we never see the system. It's so, so there, like people have to come up with all sorts of interesting constraints and promote them as being universal, while they do not necessarily are. They are not necessarily universal. So this is the thing. But I want to point you to something
pause
else.
for a second. I mean, it's funny, right? I think, right, there are certain conditions where you can't even compile or link your program with certain cycles like this.
Sure.
Is that true?
Right. Like if you have, let's just talk about Java, right? Where you have 3 classes, A, B, and C, and there's a cycle.
Yeah.
A depends on B, B depends on C, C depends on A. Like that. I believe that if there's no existing compiled thing, will it work?
Yeah, because you will have an interface, for example.
You have to put an indirection in there.
Yeah.
No, you don't put an indirection, right? But at the runtime, you will have the instances, then they will be bidirectional.
That's funny. I just want to make the observation that there are certain things where you have to do everything static. It won't even let you do this, and you will breezily, you just breezily created this, and you end up with this kind of natural way for these things to have these bidirectional cyclic relationships. I think that's pretty awesome.
So, but I want to point you to something else. So we spent the last 15 minutes talking about design. We literally talked about architectural choices, right? We talked about the principles of what is important, what is not important. And you haven't yet seen anything bearing code. We just looked at the freaking pictures of a childish board game. That's it. So now this is what I'm talking about. The design here, it doesn't really matter. This one here is seated by default because we want to get conversations like this going. But just think of this. How many times are you able to talk about the inside of the system? How many times can you want to talk about the trade-offs that we might make about the inside of the system? In a super condensed amount of, in the short amount of time, right? Very, very condensed about a domain that you haven't seen before, right? And then start participating in that conversation. For example, let's imagine that we're a team, we want to build something together. Right. The first thing we need to do when we build something together is we talk about the same thing. And the very fact that we've made it visible, and we made it visible without, this thing, anything that is called, that has any technical connotation to it.
Yeah.
This is what leads to that. And so that's one of the interesting things of moldable development. So it took us a while, so I didn't know this up front, but now I strongly believe that the most interesting aspect of moldable development is this idea of compression of communication. So
Right.
everybody talks about there's a gap between this and this. There is a need of communicating between this and this.
There we go. In fact, can
we
I
have
propose a even further strengthening of that language? It's not just about communication, but it's about something concrete, right? It's a board that looks like this, right?
Yeah.
With the ordinal indices like this, right? I think that's what you're talking about.
Yeah, no, so I'm saying exactly, because what is communication at the end, right? Communications is just a set of sentences that we can make about, for example, communication about the system. We need to formulate a set of sentences with and about the system. That's what it boils down to. The question is, how quickly can we formulate those, and how expressive are those, right? Because, for example, not two pieces of text, right, of the same length might have different, carry different, like the intent, like the density of information there, or the power of conviction might be really different between those, depending on what you've put in there, right? So this is basically, and that falls back into this communication thing. But here, right, we talked about, and this is so unexplored to my mind. And we have talked about something that actually has never been shown on the screen, right? We haven't talked about, we talk, like normally people say, oh, let's do this in lines and diagrams or code.
And the only way to make it concrete is to actually write the code. And then now you're talking about yes or no, is this the right code? I like this better, where it's like, we don't know what's behind it, but like this makes sense.
Yeah. And you can, the other thing about this is that you can also have conversations with non-technical people. This is going to be a little harder here to explore in this context, because the domain is not that complicated, but maybe a little bit afterwards. Okay, so up to now, that's these are some of the things. Now, of course, as I said, what we've done was we built this one kind of test driven, or of course we represent tests as examples in our case. So we kind of had so here's one of these examples. So I have something like B enters play with A on start square. So I have here a B to play with A on start square. That's the game. And then I'm going to assert that the one that is in play, the A is in play. So great. Then I'm going to roll a 6, and then I'm going to move the token name B. And then I'm going to assert that the position is 11, that the current player is B, and then the token is in start state because it probably captured it, right? So, but I don't exactly know. So now, can you imagine this one a little bit just by reading the code? Can you
Yes.
imagine what this kind of is? Okay, but do we know about other things? Is it just A and B in the play, or are there something else in the play? We don't know yet, right? And is this going to be the A? Is A going to be exactly at position 11 or not? I didn't write this here. I could have written this one there. But there's another option here. And if I go into this other example, right, because B to play on A and start square is another example. Right, that's the other state that I was looking at. And here I can say, oh, look at this. Yeah, A is on position 11. I can see it here, right? And this is why doing position token B at position 11 kind of makes sense.
Yep.
Right, it works. Right. And then what does this one mean? Well, this one was this one, and this one was that one, right? So this is kind of nice, right? I can kind of read it like this. But then, of course, I still have to squint very hard. But what about I do this? So I'm going to execute now the inner one, right? And I'm going to execute the one on top. And then I'm going to execute this one. So this is interesting, right? This was, okay, right, because A went multiple times until it got here. And then I'm going to do this. So now it kind of makes sense. Right. And now it's interesting, right? Because I did the same thing that I've done exploratively before. Now I've done it. Now I'm combining the testing. And now I can see, because one of the expensive things when you're doing test-driven development is find the interesting assertions. And sometimes you know how it should be. You just want to document that one, right? So for example, when you're in a REPL base, it's how often do you just say, oh, I really want to take this expression, print the result. And then I'm going to take that result and transform it into an assertion, right? Because that's exactly what you want. You've just discovered that this is an invariant, which is great, right? Now let's put it as an assertion. Let's just document it like this. And now I can actually do multiple of those things, right? Because look at this. I have multiple assertions here.
Yep.
Right? And with these multiple assertions, I still have to piece them in my head. But if I communicate them like this, which is what the intent is of these assertions, my brain doesn't have to work so much, right? It's much more comfortable. So now I'm creating another kind of conversation, right? So how often do people say that, to understand the design of a system, start from tests, right? Because it's great. It's great to start from tests and then build on top of them, right? But this perhaps has a different meaning now. Because when I start from this test, I go here, but then I can equally go here, and then I can do exactly the kinds of explorations that I want because there's completely unbounded here, right? And I can go and explore the code if I want to explore the code. And then build things in that way.
Yeah.
Right. So the exploration, right, is the interesting thing. The other thing here is that every time we reason about a system, we want to, most of the time, the most interesting sentences are those that cross-cut boundaries of abstractions. So different meta levels, right? Or sometimes you want to say how something is represented, somehow something, is manipulated at the same time, or how something is stored at some, in your JSON thing, which is another thing. Right, that you want to sometimes just formulate multiple sentences or the same sentence in which I put together multiple perspectives, which means that the environment should never confine me to something predefined. This is why right here, right, within a small amount of space, I went from understanding dependencies between tests to actually taking a look at some tests. Why did I take a look at this test, by the way? I took a look at this test because this is how I reason whenever I see a bunch of tests. I always go from left to right because these give me the bigger picture. right? And if I do not have these dependencies, I just gonna have a flat list of examples, right? If I have them like this, I don't know which is more interesting than the other. Okay, so
Yeah.
we went from this one to then looking at this piece of code, and then afterwards to exploring things and going all the way to the code or to some visualization of it, all within a very short span, basically. Because, and this is the other thing, right? How do we accommodate these unanticipated, potentially arbitrary, sentences formulated at arbitrary levels of abstractions? Is basically you do not want to constrain the whole sentence. You're just going to provide little pieces that are very quickly assemblable.
Yep. Hey,
Right?
Eric, can I, just in case if you didn't catch this, can you pan left? Can you open up the code for B to play without a square, right? And then, yeah, there we go. It's, just in case if you missed that, Eric. I mean, like how awesome to basically be able to cascade how the state got built up.
Yeah. That's
so this
cool.
is an example, right? It goes A went from here to there, right? And then B captures it and A goes there. So now all of these things are not just explorations in my REPL, but they became examples. And now they can tell a story. Right. And so, but because of the design of the whole environment, right? So one of the things that you mentioned at the beginning was this idea of REPL driven development, is that like the whole experience has to facilitate it. And that's exactly what you see here, right? There's no, it's hard to say which part of it, right? It's not just the visualization. It's where the visualization is, how easy it is to combine it with the other ones, how easy it is to create another one and promote it to be a visualization. But then it goes all the way to how do I express tests? Yeah. Right? Because, so
just to put a conversation on the backlog, I actually would love to hear kind of like, how did you, what was the process of constructing this? Where did you start? And like, how did you sort of stand up?
Because we go one step, because that's exactly what we need to go now next. Because this is still interesting, but we didn't get quite there yet. So one of the things here is it's still hard. Like if you look at this scenario over here, it's still hard to see, what is the state? What was the state before?
Yep. Right.
If
you're going where I think you're going.
What was the state here? Right? It goes from A to A. Like, it's hard. How did you go from here to here? Is it like even a valid? By the way, is it supposed to go this way or that way? I don't know.
Yep.
Right. So what happened here? I don't know what happened. It's still much better than just having it, there, but it's hard. I still have to imagine it. So what we saw is in here was that, well, it's actually not that nice, right? It's not nice. What I would really like to do, what would be a solution, for example, if you would imagine a solution, what would you like to do it? And now imagine the right-hand side, not the technical thing, not the left.
Yeah,
side.
I would love to see over time, what were the states? I want to see all the places where A lived, right? Yeah.
Yeah, I would either want to have it all on the screen at once, which would be kind of hard to read. You'd have to figure some design solution out, but maybe like a faded out A where it used to be. And maybe with like a little die next to it, like what was rolled.
The number. Yeah, that would be nice. Yeah.
Oh, what's that?
Oh, keep going.
Or a slider.
Yeah, right. To see all
that lets you just say, okay, this is the current state, is all the way at the right.
Exactly.
And then I can step back however many there are.
But the slider would still not tell you how it moved.
Well, you could swipe, right? But to reconstruct the how the pieces move.
But that's exactly what I've done here. That's exactly what I've done here, right? What I've said, I went from something to this, right? And now look at this. I'm gonna do this. Now, two things happen. This moved there, but it's hard to see.
Right. So let's go back to answer A, right? Project all states onto the board.
No, but I see what you mean.
But now let's see. Let's think of it here. Here, right? If I look at this board, right? If this board has no history of anything, it just has the current state, nothing else. So what would we need to do if we would want to store the transitions, for example?
Have record all the states and merge somehow, right?
and then somehow, you know, be able to play them. So which basically means that like the current state is the result of some
You could store the actual choices, right? The die roll, and then which token to move.
right
Just have a list of them.
list of those, right?
Yeah.
And then the game becomes a succession of moves,
Right.
right?
Right.
Like, isn't it interesting?
Which would, like, you, I mean, to me, you'd have to now throw away all you've done.
Pretty much, right? Pretty
Yeah.
much.
Yeah.
You would have to basically throw it and go back from the start, because now you kind of figure it out, but it's still not explainable. The driver here is that is not explainable enough, right? Now let's go and try and see this one. So I'm gonna do here
That's
and
interesting.
say
It's the driver. Like, I want to be able to understand it better. So I want.
so now I have this, which is
a
exactly the
different
same.
representation. Yeah.
It's exactly the same, but right. So let's do this. I'm gonna I'm gonna roll a 6 here, right? And play is to move, and then I'm gonna do this, and I'm gonna roll a 4, and I'm gonna move player A, and I'm gonna roll a, I don't know, 6, a 6, and then player B is gonna move, right? So these kinds of things, right? And let's say I'm gonna roll a 1, and then another 1. No, player 1 is still to move. Okay, great, like this. Then I'm gonna play C cannot move, D cannot move, player A to roll a die, and I'm going to do a 6 here. So I'm just going to move there, and I'm going to do a 1. I'm going to do this, and player A to move. So that, right? So it went there.
Yeah.
So now we can do this, right? So now I have the moves over here, and now I can see what happened here. Right? And because here C and D couldn't move. So now I do this, and this is interesting, right? Because now A takes B and B goes there.
Right.
Now you don't have to think.
Mm-hmm.
Now it's enjoyable. Now you can say, I really understand what this one is. Now I have a representation that really is what I wanted to see. But they really, like, literally, the driver was exactly the thing that you have just said. We looked at the presentation, and it was the presentation that drove the design. Now think of this, think of what is the idea behind both REPL-driven development and test-driven development, right? They say, focus on those and they will drive the design. The exercise that we've done here was that we left the assertions exactly the same. We did not change the assertions. The interface is totally the same. But the inside representation, the inside implementation is completely different.
Mm-hmm.
And the reason why it is completely different was because we couldn't visualize it. And so what's interesting here is that it means that if you're just going to look at things from a functional decomposition, you're going to miss another dimension. There's another force which is orthogonal to the assertion-driven creation of code that otherwise is never exercised. You would never discover this design if you didn't have to. And that's the interesting thing. Literally, This is the most exciting thing in what we call moldable development here.
I love it. By the way, dazzling. It's so concretely what you did is you create the notion of moves, and now moves know how to render themselves.
So now let's talk about, like we spent so much time, we spent at the beginning a lot of time talking about the cyclic, like this idea of cycles, because there was this mantra that went here. But what you've just happened here, like, we didn't talk about, do you have an event-driven, is your system replayable? And if you would have to choose, which one would be more important? That the system is replayable, or did you have some cycle in the system?
Yeah, I did it mostly to be funny.
No.
because it's a-
But this is so cool. It was
Yeah.
actually super cool.
yeah,
Right? But the thing, it's hard because when one thing becomes immediate, right? We're going to talk about it immediately, especially when it contradicts something that we might, we just take for granted.
yeah.
But
In
there's
fa- in
these
fact-
other things which are harder to get.
Yeah.
Harder properties that are harder to get, like this one, like to have so here we have an immutable domain model, basically.
Right.
Because the moves, right, the game state just accumulates. I
Right.
cannot change the game state.
I love it. I think the half funny comment I was making, right, is that the reason why cycles are bad is that you end up in a situation where to make something, you change one
Sure.
place and you have to ripple the change everywhere else, right?
Absolutely.
And once you make a cycle, you get in a condition where you might not even know you're in a cycle. You have to keep changing
Yeah,
things around.
you
and around.
can't change
course.
it because there's no beginning.
There's no
There's
beginning,
no
right?
first thing to change. Yeah.
And I think what you're showing here, right, is like, oh no, there's a way to do this where you can change everything you need to, despite these cycles, because somehow like there's enough independence between the pieces, right? And
Because
yeah.
they have interfaces. I mean, not like in Java where you actually have a construct, a language construct called interface, but because things are calling the same methods as they were before, there's some indirection. And that lets you change one piece and the system continues to work.
Right, right. So very provocative.
But that one, right? So, and I still think that one is, like, would you want to keep this design? Let's say if you would go and want to, represent it store it in a database now. Would we want to keep the same design? Maybe not. Right? Most likely not in the database. It will not appear like this. But from my conceptual domain, from my conceptual model, I do want it like this if I want to facilitate queryability. But interesting enough, right? One of the things that is not so visible with this, we should do that next for the next exploration, is that actually, when you're doing this, so this is I'm now alt clicked on the move to show you what I have here, the method here, and this method doesn't have any context, but in fact I can actually create it like this, and then it will have an inspector context here. So basically everything that is on the left is available. It can be available in a view that creates this one. So if I want to make the square or the move be able to draw things, if I have it within the context of a browser that I have like this, I can do it. So when I'm going to browse, moves here and then see the move over there, I can just do it. But if I would inspect the move by itself, I wouldn't know it. I wouldn't see that view, kind of thing. So it's possible to carry to have a more functional decomposition. So if you have a functional model or a layered model, basically with no cycles, it's still possible to carry the upper context to the lower one when you want to visualize. So just for the purpose of visualizing it. So these views can get arguments, basically. So you will be able to drive this one, but still that conversation is put there just so that we can have this one. So I'm so happy that it worked from the first shot to have that thing. But here, this is not the first time we saw this. So this property of keeping the same assertions, with the only difference being that, but changing the implementations. And the reason to change the implementation is just because you want to visualize something that is more interesting afterwards.
Yep. Can I propose in the remaining 20-ish minutes, can we kind of complete the quote demo and then also reflect, discuss.
Yeah, I just have one more thing to show you and two more things. So now we have this, but of course we can also go into the book now, and here we can talk about this one here, right? Because now if we if we want to document the system, now we can, right? So here is the history of the game. And what's more interesting here is that you can, so this is something that you can say, okay, this is a context. I can see how it happened. You can imagine now yourself into a second level support type of scenario. There's some exception somewhere and you want to know where's my system?
Totally.
Right. And so now those things that actually we use to drive the design are the same tools that people that want to reason about it when they have some sort of issue. They can use exactly the same tools. And we've seen this one over and over again. But then you can also do it some other things. So now imagine you want to write a user manual, right? So that you are onboarding new people into a system. And you say, for example, here are the contracts that the system should live by. For example, here we talk about moves, right? Simple case. So we can say here, what kind of moves are possible? Well, this is a move. This is a regular move. This is a move to the end of it, right? So you go here to the end. But this is an impossible move. I wasn't able to move, even if I had. So here, if I do a 6, I can't move. So it's 1, 2, 3, 4, 5, 6. So I cannot move. But then this is more interesting. So I have a situation here where I have the A did the 1 and then it moved here, but the rule says that if the token is of your own, then you have to jump over it. Right?
Roger.
So that's another move. So this is an even more complicated move. So here A moved here, then afterward, the capital A moved here, afterwards it moved there, and then D, which was here, moved here. This is the most complicated move you can have in the Ludo game, right? So I can also use it. I use the same things, but now I assembled some narrative, for example, from a user perspective. But then, of course, because this is a moldable environment, you can also assemble narratives about the technical nature of things, right? So here would be a diagram, for example, if you want a UML or so.
The fact that you can write documentation that has visualizations from the actual, scenarios that are generated. I mean, that's amazing.
That's awesome.
It's super.
But the thing here is that this documentation is simply a side effect, right? Because the only thing I've done there was I assembled. I've just done my normal TDD.
Sure. No, exactly.
Or example thing, moldable.
That's what's cool.
And then the cost of documentation is basically it doesn't exist, basically. Right. And then within the same environment, in the same concepts, you can also document the technical nature of things. Right. And or maybe some sort of diagrams over here.
Those are immoral cycles.
Right, exactly. There it is, right? In there, in this one, for example.
Love it.
For example, it has that one. Yeah, go ahead. You wanted to say something.
No, I already cracked my joke.
So can I just comment on this? It's awesome. And I'm having all these I think they're flashbacks to when I was doing Java and my object-oriented training in Java. And feeling like if I knew the language better, these things probably wouldn't scare me. Right? Like, I'm sure there are ways around all of the objections that are happening. Of course, hold on a second.
I'm just using this time to ponder as well.
Because I'm sure if I said something like, one of my objections was, sure, you have a nice list of game moves, so you can have a whole history of a game, right? And you could even probably record multiple games.
Yes. You can
But
fork a
then,
game.
like, I would want to do stuff like, well, now I want to query, like, how often does a player land on another player's token and send them back, right? And
Yes.
to me,
While we wait for Eric, can you very quickly, just kind of, what was the sequence to build? I'm just gonna guess. You're creating a kind of step one is to create some representation of game state and be able to render it. And that was actually kind of way up front to be able to create the visualization of game state, player state.
Yeah, first of all, the board.
Nice. Yep.
First the board, right? Because that's like the simplest thing on top of
Yep.
which you build. And then, yeah, and then try to drive the algorithm. And at that moment, right? First, we actually, the first part with the default game was pretty much driven without views, just assertions, and just try to get and have like build the game as one would do it, with the only outcome, or the only thing being the board, and just to be able to interact with it and build the game.
Right.
And then we added, this was the exercise. The only afterwards we said, let's now add, let's go through the process of adding and starting to tell stories about our system. And this is when it started to grow. In fact, at first,
in service of presumably correctness of game moves.
Yeah, we did find the bug, but still the explainability, right? We have to optimize for that. That it is worthwhile to stop and do it. So for example, one of the things I like to ask people is, have you ever rewritten a functionality that works as you expected? And nobody has ever done that. And this is like, it means that they got the structure right the first time, right? And you never get it right the first time. So the question here is, what kind of incentive do you give people so that they know that they have to rewrite it? How do you know that you have to rewrite something? So, like, you know, if you read
actually, Eric's back.
TDD thing.
Yeah. So he was saying objections.
oh yeah, I mean, okay. I mean, I'm just saying that that I'm sure that if I knew how to program in Smalltalk better, that I'd be like, oh, that's not a problem. This is actually like, that's perfect. But I don't know how it would be perfect. You know, part of the objections I have is in Java. I have tried it, and I know how hard it is to like represent something. Like all of the things you make are actually hard to use in multiple ways. You can make it easy to use in one way, but you can't then query it in some other way, right? You can't, like, it's hard to make like, okay, an aggregate that will sum up all of the moves that are filtered by a certain thing. Like that becomes really hard. And I don't know, I just have this feeling based on Tudor's like facial expression, that this is like actually not hard in Smalltalk. And so anyway, I wish I was a stronger small talker, because I don't know. Or let me just say, it makes me realize how not strong I am. That I'm even resistant. I'm like, oh, I don't want to go down that road because I've been there, but I've only been there in Java. So I should be more open-minded.
It's like I like to watch movies about courtrooms in the US, right? And then you have the objection, right?
Yeah.
And then the judge tells the jury, disregard this thing.
Yeah.
Right?
Forget
And it's
all
so
the last
hard.
20 minutes.
It is like, how is this? How do you expect them to disregard the experience that they just had? It's so hard, right? And it's really a terrible thing that people get exposed to whatever people, right? This is one of those cases. You have a term, object orientation, which was not the intended one. And then people took some things out of it, which was the least interesting parts of it, right? And put them somewhere else. And then people see that one and says, yeah, that one is bad. So yeah, it's an unfortunate course of events, often difficult to avoid. But that said, that cycle, it doesn't mean that it's good. I'm simply saying that a cycle is a trade-off between modularity and ease of queriness. How quickly can you query that thing? And when you explore, if you can quickly do something from self, it's so powerful.
Yeah. In fact, for the recording, can I just walk through the post to substantiate why I'm reacting the way I did, and partly to be funny, but I think just to put a point that these aren't actually contradictory, which I think is so great. So I wrote this Twitter thing from Scott Washington, who's an F# guy, but it was so great because he's saying, when you have cycles, all the work you do, when you get in a situation like this, all the work you did to modularize has basically disappeared, right? As Eric said, you have no beginning. And right, cyclic dependencies are evil, right? And he actually does an inventory of like all of the shapes of dependencies in C# and F# and how much simpler F# code bases are, right? And all the benefits that accrues. Anyway, just
no, I think that's really true. I'm actually working on cyclical dependencies in some modules at work, and they're hard to detangle. Like it's really hard. And that they must have grown organically, right? Like this thing existed, so we could add a thing from this side to query that thing, and then and now we can add another thing to the query that thing, and they just kind of you couldn't build them like that from the beginning, like to be cyclical. It just wouldn't make sense. Like A depends on B, and let's make a B that depends on A. But the other thing, though, that I think like an insight, I think that came up with what Tudor said, is that there's interfaces that you are calling a method, right? You are sending a message. And so you've always got this kind of implicit indirection that allows for the things to change independently.
Yeah,
and
exactly.
So each one is its own beginning. That's the whole thing, is like each thing has a self, and it sees the world outside of itself from its perspective, right? And so you can start there and then make a wave outward, and we somehow can break the cycle in our brain.
Actually, that's super interesting, right? It's like, what is the opposite? It's like when you deliberately don't allow things to see the world, right? You can only see your little piece that you've been allowed to see, and you can only
or like the way I was envisioning the model is there's only one view. There's just the top down. Like the number 4 doesn't mean anything outside of the game, right? But inside of the game, the number 4 means that spot. And so you have to be within a game for 4 to make sense. Likewise, with the there would be a little, I don't know, it would be a map or something that would map the token to the position it's at, right? Or maybe it's not a map, maybe it's like it's two directional, right? You could say, well, what's at position 4, and it would say A, right? And but then that would be meaningless outside of the board. Like, what does the number 4 mean, and what is an A? The symbol A or whatever I would use.
So, Eric, Tudor, I think the mind expanding. Imagine if you have these data structures that are not a tree. That's cool. I mean, that's certainly one of my takeaways. And how much power does that afford you?
What? Which part? Which power?
You have all these the game, the die, the pieces, the moves, all sort of like able to potentially call each other, send messages to each other, right?
Right.
And be able to render themselves without the constraint of A has a B and B cannot know of A.
Right, but it's possible. So we can, still do the
totally,
views. We can still do the views, right? So if you think about at the end, right? If I look at the piece, the board, the thing that the UI, that the end user sees, there's no square, there's no token, there's just something, and there's A, right? We just created those layers because we wanted to, but obviously at the end they have to come together.
So can we wrap up,
Right.
shoot to wrap up in 10 minutes? As like,
Yes.
I would love to hear kind of like, Tudor, what were the learning objectives of, after once it's through that demonstration, what did you expect the learning objectives to be? And then I would love to hear from Eric, and I'll go as well. It's like, okay, here's the insights that we took away from it.
So what we wanted to do is create, first of all, like a playground where we can talk about not things that are outside, but to say, how does moldable development, how can you explain a system, and both technically and from a business perspective, so different audiences, and how can you have conversations about design without showing even a technical diagram, not like definitely no code, and maybe just some technical diagram, right? So this is first one, and the second one was to have another playground where you show that the visual, the focus on visualizing the system is an orthogonal force to drive design. It's orthogonal to testing.
Yeah.
And this is a hidden, and this is why we're saying that multiple development is a new feedback loop. If testing was a feedback loop, so is this one.
Awesome.
And this is just one of them, right? And then of course it leads to, and then the third thing is the fact that you can piece together documentation that you can give to people that have no background whatsoever in programming, and you can still formulate, things that make sense for a reader. So
Playground is a communication tool. Third was documentation. What was number 2?
Number 2 was that is this orthogonal, it's a feedback loop that is orthogonal to a functional decomposition of the system.
Love it. Cool. I think for me, the starting point about like, does it have to be a tree? Like, well, what does that open up? Just I think a lot. And then 2 is, again, the notion of like at the earliest stages having some way to visualize. By the way, approximately like order of magnitude, how much time does that Ludo demo take? Ludo game
to build,
yeah,
to figure out and to design the whole thing. It's probably about I would say a week of effort.
Awesome.
I mean, but it was also to put the whole thing,
For sure.
and also to think what are the interesting representations and so on. So everything, and how do we achieve teaching objectives, things like this. So
Love it.
not only the technical part.
This makes me want to make a little board game. Seems really
So
like a good.
by the way, this
exercise.
one is in this one
Yeah, it's in
is
there,
already
yeah.
in GT, and it's in the book and the demo.
That's
system.
cool.
Both versions of it.
Insights, and where do you want to go next, Eric?
Insights. I mean, I think that why don't you go first, Gene?
I did it. Everything doesn't have to be a tree. Opens up magnificent possibilities. And the second one was about visualization at early stages. Where do I want to go next? I'm gonna wait till after Eric for that. But the observations for me was the incredible things that, like, not being restricted to a tree DAG type thing in terms of call stacks, calling patterns, and then that power of visualization at the early stages. Like, again, how impoverished we most of us are in terms of ability to visualize.
Yeah, I'm really curious how much visualization happened like right at the beginning, right? Because we saw a very complete looking game. So I'm curious about that. And like how early you jumped into like, let me draw something, right? Because that seems like a good skill for me to have. It's like, you know, like I just imagine I'm coding, and you're like, wait, draw a picture before you code more. Like, okay, so that's one. The other one is back in 2007, I had already been into Lisp, but I was still doing Java. And I remember I started reading all about Smalltalk, watching Alan Kay talks, like just trying to really understand, because Java did not feel very good to me. And I was just trying to understand why OO at all. And just a second. Okay, so I started really going back to first principles. What is OO? Why are we doing this? Where did it come from? And the end, and doing Lisp as well, like what is functional programming and building that side. And the end result was I felt like I was just rooting out all the things I learned about Java and design patterns and all this stuff that was like working around the language and like, why are we doing it this way? And rebuilding everything functionally. And that took years. And so now when I see what you've done, which is using a lot of stuff it's similar to what you do in Java, but it's probably, like you were saying, like it's more complete. Like, oh, it doesn't make sense to have just this. You need this and this and this and this and this, and then it works together. Whereas Java only gave you the first part. Now I feel like what I need to do to make progress down this road is to maybe soften my distaste for that thing, the warning signs and flags I put up, for the Java thing, that first step, just soften that so I can then build the rest of it and see, and then it'll glow and it'll feel good and everything. So that's what I'm thinking. It's my insight.
And where would you want to go next? A board game, perhaps?
Yeah, I think I would make something like, oh my goodness, hold on.
Let's recover that piece of data from Eric. Oh, poor Eric. It's a kid at home. So, and I'm just looking at what I want to build. By the way, great demonstration, Tudor.
Yeah, so as I said, like we're searching for ways to express this. This is one of the aspects. There are others. So we still didn't show here, how do you deal with hard problems? Problems for which there is no immediate
Oh, back there.
representation.
Apologies.
No, poor kid.
I know she's tired. It's
Yeah.
actually, she needs a nap. So where was I? That was my insight.
Yeah.
And where I want to go next is, I think, a simple board game. First thought is checkers, but maybe that's like Ludo. The thing about Ludo is there's like almost no choices to make. You know, you just roll a die, and then sometimes you get to choose between the lowercase b and the uppercase b, which one to move. And so that might be a better game, something like that. That's like in like a Candyland or something. Just like move around the board and roll the dice, something like that. Although checkers might be better for, there's more to explore in terms of like, what are the possible moves? How do you visualize those? And so maybe I'll do checkers. What do you think, Tudor?
That sounds good. That's one interesting way. And so one of the things you ask, what was first? When did we start to go into visualizations? So one of us, so Oscar, was still exploring moldable development. So we said, you start by just doing test-driven development kind of development, by just explaining, building examples. Mm-hmm. So pretty much the things that were driving that part of the exercise, so the first part that I showed you, was just create the element that you can click on and interact with,
right? And
the game. So the first part of the game, the first incarnation of the game. Then we started to explore. So one of the things, for example, was that the board, the element, the UI, had everything in it with the roll and the die and the feedback. But
all
then when we wanted to use
to be shown,
all this, and the UI that the end user would use, right? So to guide the end user. Mm-hmm. But when you want to just show, let's highlight the square, we don't want that. So we had to take it away. And it was not obvious that you have to, or it's nice to have the feedback part decomposed from the basic board part. But then it turned out that it was like this. So everything that you have seen after the first two panes came in the second part, where we started to drive the whole exercise through visualizations. So the first one was just plain TDD. Then the second part, we started to say, okay, now let's visualize and explain what happens here. And then we got to the point where we had this nice scenario where we move this one and then move that one and then move that one. And I can show each of the state. And then I said, it's still hard for me to understand what happens there. Is it good? Is it not good? I don't know. Yeah, and then we wanted to draw the arrows. And that's what drove the rest of it. So,
got it.
But
I like that. So the TDD first and like show the example. The example should show what happened. Like what's the state after, that this scenario sets up. Yeah, that's cool.
So, and the, because, Gene asked what were what are the teaching objectives with this kind of exercise to work, for example, when we coach people or give it to people that want to learn. So there are these three things. First of all, is to show how you can formulate these kinds of sentences about the system. You can talk about the inside of the system, talk about the design of the system without showing anything technical. Right? We just had a very long conversation, and I didn't expect it to that it worked like this, but it worked. So and that was interesting. Which means that those kinds of, there are ways to express this. There's so much. If you go back into what people think, oh, to explain the technical things, you have to use UML, right? A fixed language for highly sophisticated technical people, which then does away, like it closes the door for 99% of the population, which is why, if we want to have people invite here, then it should mean that we should be able to present the internal of the system in a way that an external person, that without understanding of how the details work inside, they can still have an interesting conversations, right? This is the whole idea of a ubiquitous language, that it has to live everywhere, which means that you can formulate against it, right? So that was thing number one. Thing number two was to show that moldable development is an orthogonal feedback loop to the test-driven development one, right? And this is why the second part, and you can even see it in the way we've implemented. The second one is simply a subclass of the first game. So the recording game is a subclass of the default game. And the superclass has side effects and the subclass doesn't have side effects. So it has a functional decomposition. So it's interesting, even if we're programming in what people call object-oriented, it turns out that the design becomes functional. If you're driving it with visualizations, if you want to depict transitions, right, the time, that's when it becomes functional, inevitably, right? You do not have to give, like force people to, you incentivize people
it
to purchase
happens
that design
naturally.
Yes.
And that's,
then
go ahead, sorry, I thought you
and then the third design principle was to say, by doing this, you can assemble conversations, you can assemble documentations very quickly put together, narratives very quickly put together, then you can then afterwards give to others to do it. So these were our third objectives.
I propose we pick a time for the next, anything else before we stop recording? All right, thank you, Tudor and Eric.